Hello friends, welcome to my YouTube channel is Aviation. Here we discuss about the short simple topic about aviation field. Today's topic discussion is that what are the different types of aircraft wing. I have noted down some 9 different type of wings and I will be explaining about the positive and the negative part of each type of wing. So first is the rectangular wing. It is the example of a Piper PA-38 which is a small trainer aircraft, fixed wing aircraft, and they are the simplest form of wing which is easy to manufacture. They are being utilized in a smaller aircraft only. It's a non-tapered straight wing. Tapered means if there's an aircraft, I've made a top view. These are the tapered wing. Tapered as in the chord is changing from the root to the tip, which I'll be discussing further. But here in the rectangular wing, the wings are straight. Major issue, it's a non-aerodynamically efficient. Why? Major issue is that I'll make a front view of the aircraft. So this is a rectangular wing. The lift generation is even throughout the wing, which may lead to the bending of the wing. It's too much exaggerated, but you can understand because of the cantilever part. This is the first reason. Second is these aircraft cannot go very fast because of the generation of shock wave as the aircraft reaches the transonic range. So there is a subsonic which is the range up to 0.8 Mach. Mach is the speed unit. From 0.8 to 1.2 Mach is the transonic zone where the shock wave started generated, where the sonic boom and everything happens, and above 1.2 Mach is the supersonic range. So these aircraft are the subsonic aircraft and the smaller aircraft in which the rectangular wing is justified to be fitted on. Coming next is the elliptical wing. So elliptical wing are the most aerodynamic efficient wing. This has been mathematically proven. So what happened? So I'll just again make the front view, and the wing which is attached is the aerodynamic wing. Because of the design of the wing, the lift generated at the tip is less, and the near the root is more, and this is known as elliptical lift distribution, which is the most efficient way of the distribution of lift. The bending issue of the wing does not comes into this issue, and also the vortex generation, because at the tip of the wing, because of the low and high pressure below and above the wing, the vortex generation which is happening does not affect much of the lift. So that's why these are the most efficient wing in the complete wing structure. The only issue is that the manufacturability is poor, because as you can see the design, and again they are used in the smaller aircraft only, the aircraft which can fly in the subsonic range only. Next type of wing is the tapered wing, which is actually this is the tapered wing, is the top view, and which is actually the mixture of the elliptical wing and the box of the rectangular wing. That's why I've written it's a compromise between manufacturability, in this the manufacturing is the most issue in the elliptical wing, and the efficiency is less in the rectangular wing. In tapered, we are compromising both. We have given a tapered. Reason for tapering is that the air which is coming straight, or which is interacting, a part of the air, so this is air flow which is hitting at 90 degree to the wing leading edge. This is leading edge, this is trailing edge, this is tip, this is root. A part of it only leads to the generation of lift which is in this direction. That's why this aircraft can go faster, and the aircraft can fly into the transonic range also, 1.8 Mach to 1.2 Mach, and go further also if the aircraft engine's capability is that much. It is having an elliptical lift distribution, which is the most efficient way, which I have already discussed in the previous type of wing. Chord is varying from root to tip, which I have already discussed, and this is the P-51 Mustang, generally at the time of the World War II. Next type of wing is the delta wing. So delta wing, as we know, the shape of a delta is this. So as you can see in the figure, this is a delta wing. It has a lot of advantages. First of all, it is having a low aspect ratio. It's not actually an advantage. Low aspect ratio means the vortex generation is too much. The leakage of air from bottom to top because of the pressure difference leads to the formation of vortices. So low aspect ratio leads to high induced drag. High induced drag means you should be having a very powerful engine to overcome this drag. Correct? They are used in supersonic aircraft. Why? Because of the tapering, as you can see, there's too much of taper, and only a part of air is actually leads to the lift, so the aircraft can go further without the wings goes into the shock. Correct? Which I have already discussed. So they have a large area. There's a wing loading and is reduced, and maneuverability is high. Wing loading is a per unit area of the wing, how much lift is generated, because the area is high. Okay, So lift is equal to weight is equal to half rho v square s cl. This much if we divide weight by s, which is equal to half rho v square cl, this is known as wing loading, which is the weight per unit surface area. So the surface area is too high, so wing loading is reduced, and since the wing loading per unit surface area, how much lift is generated, or particular area, how much weight it is carrying to generate the lift. If you know the idea. So wing loading is reduced, the maneuverability is very high because it can take further load. So will not go into depth of the wing loading and the load factor. The maneuverability is high in the delta wing. The structurally is strong, as you can see, it's a huge mass chunk goes into the wings because it is having a large volume, so fuel can be filled more. That's why the range of the aircraft can be increased. They're simple to manufacture and maintain, so it is having a very high positive point. So for the wings, next is trapezoidal. It's a small twerk into the delta wing only. So in the trapezoidal, it's like a kite. As you can see, it's like a kite only. The trailing edge, so if this is the front and this is the rear, so the trailing edge is sweeping forward and the leading edge sweeping backward. It can go on a supersonic range because of the previous reason we have already discussed, because of the angle, and having outstanding performance. It's one, you can say, a sub part of a delta wing. So generally kind of which country likes to manufacture what kind of wings, and they have that assembly line of that kind of wing. So generally F-20 is a US made aircraft, and US generally have this kind of wing structure in their aircraft. Coming back to the next to the swept wing, back wing. So in the tapered we have seen this. In swept wing, the complete wing is swept back. So if you can say this 90 degree, there is some angle, the angle is further increased, theta 1, theta 2. Because of the angle is further increased, the aircraft can go further faster, and also it is being tapered, and at the tip is very small as compared to the root. The induced drag is reduced, the vortex generation is reduced. So generally these kind of wings, there are long wing also, and these kind of wings have a maximum performance in the transonic speeds. That's why they are used in the commercial aircraft, generally in the commercial, as you can see. The example is a Boeing 787-9 Dreamliner. I hope this much you have understood. Next kind of wing is forward swept wing. They are generally not used in the aircraft. There are very few experimented aircraft in which these kind of wings are used. Reason is that the outboard or the tip, they generally get into shock earlier as compared to the root, and the control surfaces here at the trailing edge, they get into the shock. That's why there's a controllability issue. So these aircraft are generally for the experimentation purpose only. But yes, this is a kind of a wing. They have a controllability, they have a high maneuverability as compared to the previous aircraft, but it's a trade between both. Next is the variable sweep wing. As I've told, the long aspect ratio wing, having a good span, they use in subsonic aircraft, the aircraft which cannot go further higher speed because of the shock issues. These kind of aircraft can flow in supersonic because the drag is less now, and the aircraft is flying at a very high speed. So it's optimized flight experience over the different ranges of speed. So this is one advantage of the variable sweeping. Only disadvantage is that the mechanical complexity the manufacturability of the wings and then their fitment into the aircraft, that remains an issue into the variable sweeping. So I hope with this video you could have got some idea about the different type of wings, where it is generally used, how it is used. If you have any query about the wings, please let me know in the comment section. I'll definitely address your issue, and please share this video to your friends. Let's make the aviation easy. Thank you.